Okay, welcome. For those of you who don't know me, my name is Lou DeAndrea. I've given talks in the past on Dynamic, on DynamicModule, on Manipulate, and today I'd like to break that mold just the slightest little bit by talking about other aspects of Dynamic that tend to get short shrift at these conferences, but are still very key in sort of building nice, round, usable interfaces. I'm going to go fairly quick. This notebook is already online at the talks page on the WTC 13 website. You can hit me up afterwards for it. There's going to be a couple of sections in this notebook labeled bonus, which I will not open during this talk. Those are for you, for tonight, for when you go home. Feel free to contact me as you go through them and you have further questions. Okay, so Dynamic is this wonderful thing that we've had since version 6, where you have variable-based updating, you have a little bit of time-based updating. Then we have a set of controls. It was first, we had buttons starting in version 3, which supported mouse clicks. Starting in version 6, we had things that support mouse down, mouse drag, sliders, pop-up menus, locators. We had a little bit of support for mouse over, including things like tooltip and status area. But what if you wanted to do more event trapping? So trapping keyboard events, trapping more mouse events. What if you wanted to tweak your dynamic updating so that it only happens when a particular notebook is open or when a particular notebook is foremost? What if you wanted to do something like dynamic updating without any notebooks anywhere, even without a front end anywhere? What if you wanted to do, so you can read the list. So these are the kinds of things that I hope to enlighten. And if you feel that you have a firm grasp of these kinds of things already, there are lots of other wonderful talks going on right now. I won't be, you won't offend me. Okay, so let's start with Event Handler. Event Handler is this nice, simple wrapper. You say Event Handler, you give it some. Yes, Jason.
Can you make it work?
I can. Jason is in the 4th row and still has trouble saying this. I think this might work, except for the usage message formatting. So is that better for Eric, Charles? Is that we good?
I can read it fine, Jason.
Okay. Well. Okay. So Event Handler, you take this wrapper, so you wrap it around an object, and you give it a second argument that says what events you want to trap, and if that event happens on that object, what to do when you get that event. And it takes the usual set. If you've done interface programming in other systems, you're familiar with these kinds of events already. It takes all kinds of mouse events, all kinds of keyboard events. It lets you say, show me when a particular key is down, or when some keys that sort of have custom names are down. It also lets you intercept some other events. So here's an example where we have an event handler wrapped around a grid. The only thing dynamically changing in this grid is where the highlighting is. So you see the background has a dynamic, it's dynamically updating which row is being highlighted. And we're trapping the up arrow key event by saying, well, move up the grid, move the highlighting up the grid. And down arrow moves down the grid. So now, once we click into this area, up and down arrow will dynamically adjust the highlighting. No sliders, no dynamic, well, there's some dynamics, but this is not the typical manipulate type dynamics. And return key also is bound to extracting that information and printing it out. So here we have a simple example of a region on the screen, this box that Event Handler wraps, in which all of the events listed here are trapped. And Event Handler can be wrapped sort of at any level in an expression. Here's a pair of examples that are meant to illustrate that. So we have an Event Handler that's changing the color of a disk when we enter the region of the graphic. And it changes it again when we exit the region of the graphic. So here I'll click on the graphic to show, as we cross that orange border, the disk is highlighting. Of course, we might want just when we cross this border to be the trigger for disk highlighting, and we can wrap Event Handler down one level lower. So here's the example of that, where it's wrapped not around the graphic, but around the disk itself. So here we have an Event Handler inside of a graphic. And again, I'll click on here so that you see it's not the mouse entering the region of the graphic that matters, it's the mouse entering the region of the disk. And you can have multiples of these things in the same graphic. You could nest them together. One point to keep in mind is that unlike button and action menu, event handler has no facility for triggering long-running evaluations. So button has method queued, action menu has method queued. All other controls expect that you're doing a fast, synchronous evaluation. If you don't know what that is, there's a bonus section in this notebook that links to a YouTube video from last year's conference talk. I'd encourage you to read that, watch that. So be careful. Event handlers are expecting these things to sort of be fast. And you can nest them. One issue that immediately comes up when you nest event handlers is, well, if you have one event handler around the disk, another one around the graphic, and you mouse over the graphic, the one wrapped around the graphic needs to pass the information about the event through to the underlying event handler. So the question is the event consumed or is it passed through? And there are options in event handler for indicating which to do. Here's an example, not with nested event handlers, but with an event handler on top of the front end. And the front end, of course, has its own suite of event handling. You know, you click on a graphic, that means something in the front end. An event handler on top of that can either intercept the click, as it does for this first disk. So clicking on the disk randomly changes the color. But notice the graphic is not selected. I'm clicking on this disk. I'm not getting the orange outline around the graphic as I usually would for clicking on a graphic because the event handler is completely consuming this event. And that's the default mode for event handler. It completely consumes whatever event you've indicated. And this other graphic allows the event not only to be caught and acted upon, but also passed through. So if we click on this guy, the color will change and the graphic gets selected. If we double click, the disk will get selected. And all the typical graphics editing idioms, which depend on mouse clicking, still work, even though we have this disk now responding additionally to click events. And event handlers are used in lots of different places in Mathematica. I'm not going to indicate all of them. I wanted to show one sort of neat, flashy one where we have this single equal. And for those of you at the back of the room, I'm sorry, I can't quite expand this anymore. There's this icon which lights up, not when you're over the icon, but when you're over any aspect of this pod-like interface. And this is done with mouse entered and mouse exited events, which change a local dynamic module variable which affect the display of this icon. Okay. Also key to using event handler well is the notion of current value, which some of you may already be familiar with. Many times we see current value in the notion of option values. So you can say current value of font size, current value of notebooks. But current value can also report the state of other aspects of the system at the instant an event handler is triggered. So we have current values for reading off the state of modifier keys in a session, either one at a time or getting a list of all the modifier keys that are available at the instant that the event took place. We have general information about an event. We have information about the selection, whether the selection whether the event handler is inside of the current selection in a notebook, so you have some cells selected, this one might be one of them, or whether the notebook is the foremost notebook or not. And additionally, we have even more mouse related, lots of different coordinate systems are accessible through this low level feature. So just by way of a quick example, here we have just something that shows dynamically the state of modifier keys as I'm pressing them on the keyboard. And this is nice and fast and all, but really what I want typically in an application is, well, I control clicked this, and I want to do one thing when you control click, one thing when you shift click, one thing when you regular click. And so when you call this current value inside of an event handler, as we have down here, so here we have an event handler wrapped around a framed object that it remembers the state of the modifier keys when you enter this region. Okay, so when I enter this region with no keyboard, with no modifier keys pressed, nothing happens. If I press the shift key, nothing is happening down in the lower event handler until I mouse over the region, at which point the current value fires and says, oh, you had the shift key down when this event fired. And no longer pressing the shift key, it's remembering that was the key that was down when this event fired. So the thing that I'm trying to get through is this is not the state of the current values right now. They're the state of the current values when the event was triggered. So which is really what you care about when you're supporting things like shift clicking and whatnot. Okay, and here's a somewhat larger example, which I'll talk about briefly. So here's an event handler that once you enter this region on the screen, it will check to see whether the notebook is in front of all the other notebooks, whether this event handler is inside of the selection, so maybe the cell is selected, maybe the whole notebook is selected, maybe just this graphic is selected. And if both those are true, then it checks to see what the state of the modifier keys are and changes the color of whatever this is accordingly. So clicking once on the graphic will select it, and now let's see. So now we have mouse entered affecting this. Shift key is down, it's a different color. Control key is down, it's a different color. If we put another notebook in front of it, this notebook selected current value, no, this would update if I didn't have the notebook selected there. But since we do, then this is saying, oh, I don't want, the user isn't focusing on this notebook, so I'm not going to do anything. This was used, for instance, in the joystick, in binding joystick controllers to manipulate. We didn't want joystick controllers to move all of your manipulates everywhere. We wanted it only to change the one that was currently selected in the foremost notebook. Okay, much more detailed example here for the bonus section. As I mentioned earlier, the bonus sections are for you and not to be opened during this talk. You can open them during this talk, but I won't open them during this talk. And this notebook is available on this talk's page on the WTC 13 site. So we have event handlers that can be wrapped around boxes, around content inside of cells. There are also larger scoped event handlers. These aren't functions, they're options in the front end. So we have an option for indicating events to trap at the cell level. We have options to indicate events to trap at the notebook level and also at the front end level. So I'll just give some quick sort of cute examples of this. Here we're printing a cell that redefines return key to mean shift return. So in this cell that gets created, I don't have to press shift return to evaluate this. I can just press return without shift and it evaluates. This is how single equal and double equal were implemented via setting this option in the style sheet. Okay, notebook event actions are also probably, of the three on here, notebook event actions are going to be the ones you want to remember, because if you use the built-in dialog functions, they set notebook event actions to trap the escape key and to trap the return key. And oftentimes that's exactly what you want to activate the default button and activate the cancel button. But what if you want to present a dialog in which the user might be typing into an input field and reasonably type the return key or type the escape key to enter some text? And if you want to avoid that situation, so the default will let me press the return key to dismiss this dialog, and I can avoid those built-in behaviors by removing all notebook event actions from this dialog creation function. So now return and escape do nothing. Of course, the buttons still work. It's just the events that you are now, you're able to use those for other purposes. And front-end event actions, you can imagine what that is. Okay, so events, current value, that's sort of one big topic. Next big topic are what I call implicit dynamics. These are things that update like dynamic does, but syntactically aren't wrapped in capital D dynamic. You can imagine wanting this for a couple of different reasons. The way that it's commonly used in Mathematica is to create a display separate from the dynamic updating mechanism. So to keep the code modular, we have one function one utility that's called to format the display, and another function that actually accesses and updates dynamically, just to keep code modular. And this wrapper is known as dynamic wrapper. And so here is a display whose first argument is shown, and whose second argument is updated dynamically. So I mean, you might think this is just syntax, you know, this is a little bit of sleight of hand with dynamic, and yes, maybe it is. But I think this formulation is genuinely useful. So let me show another example how you might find this useful. Here is a display that just has a slider and a couple dynamics, and you drop it into a dynamic module, and okay, well, that's nice. But what if we wanted additional dynamic behaviors on top of this? What if we, you know, this is some beautiful utility that you've spent months crafting, and now your colleague says, well, why can't you make it do this instead? So here we drop the same utility function into a dynamic wrapper that shows the same thing, but then has some additional behaviors on one of the variables. So we drag this guy around, it's updating n, we release it, and then this other dynamic that updates k fires until it stops. Again, syntactic sugar, but I think this is genuinely useful. It's used, again, I'll give the example of using joysticks in Manipulate. It's used to keep the Manipulate dynamic, the dynamic implicit in all manipulates, clean, neat, and the dynamic controlling, the controller, what am I saying? The controller interface to dynamic completely separate. And that also means it can be jettisoned if the user sets the appropriate manipulate option, which is nice to keep things modular is always good. And here's another example. You know, we might have two different plots, and we want to have an interface that adjusts both of them, and each of them might take some time to evaluate. How do you get it so that the slider that affects one plot isn't regenerating both of them? So here are two functions, one of which is artificially slower than the other. And if we looked at this in Manipulate, it would just, you know, well, let's go ahead and do it. The n slider would follow along at about 1/3 of a second per change. And the m slider, which is changing this nice fast plot, we would hope to be also fast. But it's also going ka-chunk, 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 because really there's a dynamic wrapped around the whole first argument of Manipulate. And so that whole dynamic needs to update. This whole show expression is updating every time we change either n or m. And once that happens, then both plot f and plot g get called. And we can avoid this through use of very carefully nested dynamic wrapper. So we have a dynamic wrapper that updates the value of the slow plot, and a dynamic wrapper that updates the value of the fast plot. And of course, dynamics only update when they need to, right? So in this case, we have the n is still 1/3 of a second, ka-chunk, 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 but m is now nice and smooth. Because the m, dragging the m slider is no longer changing, recomputing the other plot. Okay, so, and this would also allow you to build, so this last point, synchronous initialization for a dynamic, question mark. Does anybody know why there's a question mark at the end of this? Sorry? Synchronous initialization is an option, but not to dynamic. Dynamic has an initialization option, but it has no synchronous initialization option. DynamicModule does, but dynamic doesn't. And gee, wouldn't it be nice if it did? Yeah, okay, maybe. But until it does, we can build such a thing fairly straightforwardly with dynamic wrapper. So here we have a dynamic wrapper that has a display that's synchronous and an asynchronous initialization. Dynamic wrapper takes all the same options as dynamic, so here we have synchronous updating false, a poor man's synchronous initialization for dynamic. Okay. So like event handlers, implicit dynamics have, you know, larger scopes than just individual boxes. We have cell level implicit dynamics that fire whenever the cell is on screen. We have notebook level dynamics, and these are the names of the options. And here's an example of the notebook level version of these guys. I lobbied heavily for the names of these to be more consistent. So dynamic wrapper is quite a bit unlike cell dynamic expression, but these four really are in the same family. Okay, so that's implicit dynamics. Now for the headliner. So we talk about the box language in the front end a lot. Can someone tell me why it's called the box language? Jason, no. Can anyone other than Jason tell me why it's called the box language? Well, okay, yes. That's just the way that it was named, right? That's why my daughter's called Ellie, because I named her Ellie. Jason?
Well, it originally came from tech, and tech used boxes.
Right, so why did tech use boxes?
Yeah, that's a good question.
Right, so I like to tell myself that the reason that these systems use boxes is because they're talking about rectangular regions on the screen. And yes, region, we would call it a rect or a rectangle, not a box, but fine. Let's say for purposes of argument they're called boxes. We're talking about regions on the screen. Frame box is a rectangular region on the screen. Grid box, fraction box, these are all regions on the screen. Dynamic module box is a region on the screen that has the property that any variable defined inside of that region is local to that region. So dynamic module box is a box that localizes variables in space. It localizes things inside of this one rectangle on the screen. And this is nice, so if we copy this rectangle and make a new copy of it, this is a new value of x that has nothing to do with the old value of x. We can make a table of these things. They're all different x's running around here. And that's all fine, and it's usually what we want for building interfaces, but what if you wanted to have an interface that created some new rectangle on the screen, separate from yours, that had access to all of the same local variables and access to the internal state of your parent dynamic module? What if you had an interface that wanted to pop up a secondary dialog that said, "Are you sure?" Or, "What's your name?" And this is what dynamic module, what the dynamic module option inherit scope is for, and it's what we call wormholes. So it allows the secondary dynamic module, the secondary rectangle on screen, to behave as if, for purposes of localization, to behave as if it's inside of the parent dynamic module box. So here we have a simple example of that, a dynamic module that contains a slider that's bound to a variable. And we have a button that generates a new dynamic module in some print cell, which inherits the scope of the dynamic module containing that button. So we see now that these two guys are in fact bound to the same variable. Okay, and dynamic module wormholes have some very nice features. They're sort of finicky. I encourage you to read through this list. In particular, I want to emphasize one of the things here. You can't build a wormhole between two existing dynamic module boxes. And by this, I mean you can't build a wormhole. If you read the advanced dynamic tutorial carefully, the very last sentence seems to disagree with this. And so come next year, we might have an answer to why that is. And you can chain wormholes. You can create, so you can have one parent dynamic module that spawns multiple wormholes. You can have a parent module that spawns a wormhole to another module that inherits the scope on down and down the chain. And here's an example of that, where the print button is, in fact, spawning a new one off of the previously spawned dynamic module box. And this is used whenever dynamic module needs to pop up a secondary interface, such as the assumptions dialog in control equal. Okay, well, that's really all I had. There's a bunch of bonus slides at the end, and I encourage you all to read through those. And if you have any questions, I guess now would be the time to ask.